As the aluminium oxide becomes hot, the heat reaches the ethanol at the end of the tube. The ethanol changes into a vapor, passes over the hot aluminium oxide, and is dehydrated to form ethene. If the ethene is bubbling off too slowly, move the Bunsen burner near the ethanol for a brief moment. Allow the bubbles to escape for a short while, as these are mainly bubbles of air displaced from the apparatus. Collect 5 test tubes of the gas. Put a stopper on each test tube as it is filled. When all the test tubes have been filled, loosen the boss head on the retort stand and raise the apparatus up so that the delivery tube is no longer dipping into the water. Then turn off the Bunsen burner. If the delivery tube were simply left in the water trough, a suckback of water would occur since the boiling tube begins to cool as soon as the Bunsen burner is turned off. The cold water could cause the hot boiling tube to crack. Addition of bromine. Alkenes are more reactive than alkanes because of the presence of. Let's see what happens if we add some bromine water to a test tube of ethene. Replace the stopper and shake the test tube a few times. Note that the yellow color of the bromine water solution disappears. Potassium permanganate, KMnO4, is also used to test for the presence of the carbon-carbon double bond in ethene. Add about 1/10 of a test tube of dilute KMnO4 to a test tube of ethene. Shake the test tube a few times. The disappearance of the purple color to give a colorless solution is evidence for the presence of a carbon-carbon double bond. This concludes the study of the properties of ethene. In the next part of this experiment, we will examine the properties of ethene. Note the physical properties of ethene. It is a colorless gas with a sweetish smell. The fact that the gas can be collected over water shows clearly that it is insoluble in water. Otherwise, the gas would simply dissolve in the water instead of bubbling through it. We now investigate what happens when we burn ethene. Remove the lid from one of the gas jars and use a lighted wax taper. Apply a light to the mouth of the gas jar. Note that the gas burns with a luminous flame. Allow the gas to burn. When it has stopped burning, add some lime water to the gas jar. Replace the lid and shake the gas jar a few times. The lime water turns milky, showing the carbon dioxide has been formed when ethene burns in air.